We can determine the ratio of undecayed nuclei left in a sample by using how many half-lives have passed. So remember that the half-life is the time for the number of undecayed nuclei or the activity to halve. We can find the proportion of nuclei remaining by halving the number of nuclei after each half-life. So after 1, for example, half remain. After 2, a quarter. After 3, an eighth. After 4, a 16th. And after 5 half-lives, a ratio of 1/32 nuclei remain. This proportion will be the same for any sized sample. Let's have a look at an example demonstrating this. A source of 72 gallium nuclei decays with a half-life of 14 hours. Calculate the ratio of undecayed 72 gallium remaining in the source after 84 hours. So for step 1, we want to calculate the number of half-lives that have passed. So that's 84 hours divided by 14 hours, and that gives us 6 half-lives. In your exams, you'll never have to deal with a calculation that doesn't involve a whole number of half-lives. For step 2, we need to multiply half by itself this many times to find the ratio of undecayed 72 gallium. So we need to multiply half by itself 6 times as 6 half-lives have passed. Then we can see that after 84 hours, the ratio of undecayed gallium remaining is 1/64. Let's have a look at another example. Carbon-14 is an isotope that will decay without replacement after the death of a living organism. The half-life of carbon-14 is 5,700 years. Calculate the age of a bone sample where the measured carbon-14 activity is 1/8 that of a living bone. You won't be expected to recall how this method of calculating the age of something works in an exam, but you might be asked to use a given method like this one. So for step 1, we need to calculate the number of half-lives that have passed. So the activity is now 1/8 that of a living bone, and that is equal to half times half times half. So that's 3 half-lives. Then for step 2, we need to use the half-life of carbon-14 to calculate the age of the bone. So that's 3 half-lives multiplied by 5,700 years, which is the half-life of carbon-14, to give us 17,100 years as the age of the bone.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!